Okay, we're going to use this graph to the right to find the value of sine theta. We talked about yesterday, that's just a way of saying that this particular angle measure for each value. Now, I want to start with one that's a little bit easier. So let's actually start down at number 4, and then I'm going to go back up to number 2 here in a second. Because number 4, pi over 2, I'm like, oh, pi over 2. Oh, it's this point right here. So it's basically asking me what's the y value at pi over 2. And I come over here. I'm like, oh, it's 1. Okay, that was easy. I like that. But not all of them come through quite that simply. Because then I get to the next one, and it says 7 pi over 4, if I'm looking up at number 2. And I'm looking like, oh, I don't see 7 pi over 4 up here. How do I even know where that is to be able to try and make a guess? So here's what we're going to do. First thing I'm going to do is I'm going to color in my axes a little bit deeper here so I can actually tell where they're at. Because that's going to be important to me. Because we know, of course, that we start at 0. And maybe if I can fill in some of these lines in between, because they give me pi over 2, they give me pi, they give me 3 pi over 2, and they kind of keep looking, maybe I can figure this out. So we talked a little bit yesterday about how I can figure out what's in between 2. Like here, I'm trying to figure out, well, what's between 0 and a half? Because pi over 2, if I put a number in front of pi, it'd be 1. So if I don't remember what's in between 0 and a half, we talked a little bit yesterday about how I can use the calculator to help me figure that out. So we'll take a second here. There we go. So if I'm not sure, I can always take the two values that I have. So in this case, that'd be 0 and 1/2. Add them up, and then divide by 2. Because basically, I'm looking for the midpoint. But I don't want a decimal. So this line right here would actually be pi over 4, or 1/4 pi. And so I could keep doing that for every single one of these lines that's missing, but you know, that could take a while, but it would work. But you're like, well, what would be a better way then? Okay, here's my alternate plan. Okay, so this is 0. This line is 1/4. What that first line tells me is every line after it's going to be another 1/4. So basically, this would be like 2/4 and 3/4 and 4/4. And I just keep going, and you're like, okay, so what good is this doing me? Well, let me tell you what good this is doing you. If you start looking up above, let's kind of see where a connection could get made here. 4 over 4 is 1. Okay, that's pi, or 1 pi. Oh. 8 over 4 is 2. Oh, that's the 2 pi one. So my job now, 2 over 4 reduces to what? 1/2 pi over 2. So what that can help me do, 3 pi over 4, because 3/4 doesn't reduce. 4 over 4, okay, we reduce that. Does 5 over 4 reduce? No. So this is 5 pi over 4. 6 over 4 reduces, they're both divisible by 2, to 3/2. Let me zoom this a little more here so it's a little easier to see. And there it is, 3 pi over 2. Does 7 reduce? No. I'm just going to stick that up here so it's a little easier to see. And then 8 over 4 reduces to 2 pi. Just that quick, I can do that through, and that'll work on any one of the graphs that we do. It's just reducing the fraction down. So now when I get asked, what's 7 pi over 4? I can go, okay, here's 7 pi over 4. Ooh. Well, what do I do there? I mean, it's not even on a line. What do I do for the value of it? Okay. Well, we're going to guesstimate. So I look, and I'm like, okay, so if this is 1, okay, so it's not quite to 1. So it's more than 1/2. But it's less than 1. It looks like it's in between, so maybe we guesstimate that it's negative 0.75. Okay, negative 3/4. As long as you make an answer that's sensible, okay, that's going to be okay, because we're not going to get the exact answer just from staring at the graph. Now, if we knew all of our fancy charts and stuff, we'd know the exact answer, but we don't, so we don't, so that's okay. So that's how that top part's going to go, or any time that you'd run into something that was like that. So as we move down a little bit, okay, determine the number of cycles each sine function has from the interval from 0 to 2 pi. In other words, for the graph that you've got here, okay? And again, I'm going to darken my axes a little bit so I can see this a little bit better. And then find the amplitude and period. Okay, so I look and I go, all right, so here's 0. 1, 2, 3 lines gets me to pi, if I can see it through my graph there. So 1, 2, 3 more lines would get me to 2 pi. So basically, how many times does this cycle, starting at 0, so starting here, and then it goes up and down and back to 0. So there's 1 cycle. Up and down and back to 0. 2 cycles. Up and down and back to 0. So to me, looks like we're looking at 3 cycles, okay, within that function, or 3 periods. And then we're going to find the amplitude. Again, our amplitude is just what the minimum or maximum value is. But remember, it's always positive. So I look, where is it? The highest value it goes, the highest value it goes to is 2. That's my amplitude. That's the easiest way to look at it. So again, that's not a bad deal. And then the period, remember when we're looking for that, when we're looking for period, period is always 2 pi divided by b. Okay? B equaling the number of cycles that we're looking at. Right. So in this case, my period's going to be 2 pi over 3, which tells me this value, when I got to here, if I wanted to look at it, would be 2 pi over 3. And then this would add another 2 pi over 3. And I could keep doing that as I was working through some of these. That's what we're going to look at as far as these go. So that's kind of my deal. And if I do the same thing on 6, now 6 I should have put a star next to. 6 is kind of weird, because we look at that and you're like, okay, well here's my 2 pi. So here's kind of where things end. Here's where they start. So you're like, well, with a sine curve, it's supposed to go up and then down and then back. Well, this doesn't go. This goes up and here. So it's like it's only this part. It's like it's only half of it. All it does is the up part, and it's already to 2 pi. So how do I do that? Okay, this is going to sound strange, but stick with me. Since we only did the up part, we actually only completed half a cycle, because we only did up and back to 0. It's kind of like we zoomed in just on this part before we got to 2 pi. You're like, okay, so is that my b value? It is. My amplitude still is wherever my maximum is, so that doesn't change. That's 1. But now here's the weird part. So my period, because we said the number of cycles is my b, we're going to do 2 pi divided by a half. And we talked yesterday about there's a couple of ways I can deal with this. I can either say, hey, I'm multiplying by the reciprocal. So if I flip over 1/2, it's 2. So 2 times 2 would make my period 4 pi. Or I could do it classically. I could do it if I'm more visual of a learner. I could sit here and say, okay, so 2 pi divided by a half is the same thing as 2 pi, because again, we flip the second fraction when we're multiplying. 2 times 2 is 4 pi over 1. I get the same thing. It all depends on how you learn. And that's all we're basically looking at here on how that's going to be. So not a bad idea. So that's one way we can look at it. And again, we're kind of using this as a note/help sheet, because again, we'll see this again coming up, but I want to make sure we've really got this. Okay, sketch one cycle of the sine curve. Assume a is greater than 0, which means it's going to open up to start. Write an equation for each graph. Okay, so we'll get our little sketch made here. And we talked yesterday about how we're going to have 5 points when we do this. My first point will always be at 0. And then I'm going to have 4 points after. Well, they were nice, and they gave me the information I want. They told me my amplitude. So I use the positive and negative of that value because I'm going to go up and down with these. And they told me my period, which means that's the value that goes on the last one, if I know what the period is in advance. So it's my job to figure out what these other values are going to be. So like we did up above, we're going to kind of narrow this down and say, okay, well, what's in between 0 and 1/2? Now, I think we did this before, actually. Yeah. We added the 0 and 1/2 and found out that it was 1/4. So 1/4 is pi over 4. Get that in the middle. Now I got to figure out what's between 0 and 1/4. So I got 0 plus 1/4 is 1/4. I mean, I could have put in the 0 plus, but that would take a lot of time we didn't need. And get my decimal version. So 1/8 would be, excuse me, pi over 8. And then I can build that last one. This is 1/8. So once I have this, so I've got 1/8, 2/8, because 2 over 8 reduces to 1/4, 3 over 8, which doesn't reduce, and this would be 4 over 8, or 1/2. So I've got all my values. But again, if you forget that, there is an option. I can take my 1/4 that I already had. I can add it to 1/2, because again, I'm looking for the number that's in between. And then just divide that by 2. Math, enter, enter. Okay, I'll still get the 3 over 8. So there's multiple ways to get there, is all I'm trying to say. And then again, with my graph, with my sine graph, we always start at 0. And if we open up, we go up to the max, back down to 0, down to the minimum, back up to 0. We're always going to get that curve that goes above and below the x-axis. And then I'm set. So then when it asks me to write the equation for that, you're like, okay, the equation. Now, how's that work again? Okay. We talked about with our equation. Let me scooch this over so we got some more room over here to the edge. Okay. Is that we're always trying to figure out, okay, A is my amplitude. Okay. Now my B value isn't the period. We'll talk about that in a second here. We'll figure this out. We've talked about before to find our period, which is the last kind of mathematical thing we need to do here. We're going to do a little algebra. My period is always 2 pi over B. Well, they gave me the period this time. Okay, the period's pi over 2. So we're going to do a little math. We're going to do a mini proportion here to figure out what B is, so we can plug that in and be done. So with any proportion, we cross multiply and then solve the equation that we got. So if I want to solve for B, I got to divide by pi. And I find out that B equals 4. So plug that in there. And I've got my equation. But we're always going to take, if they give us the period and ask for an equation, we're always going to plug that into this little proportion. So like on this one, I'd set 2 pi equal to 2 pi over b and figure out what b is going to be. So, but again, it's just about getting the practice to feel better at it. We're not expecting you to be ready to, take honors trig tomorrow, but it's a good thing to kind of start with. So we'll kind of keep playing here a bit. So let's see. Okay, when I get to this next one, I got to be careful of a couple of things. We talked about this a little bit yesterday. My A value is -2. Now that doesn't mean my amplitude is negative. Right, my amplitude is still positive. So I'm still going to have 2 and -2. It's not like -2 gets put above the x-axis all of a sudden. And then again, this is my B value, just like it was when we were producing the equation a minute ago. So as we start to look at this, we go, okay, so let's see here. If that's my B, my period is going to be 2 pi over b. And then I reduce the fraction. 2 over 4 reduces to 1/2. So my period is pi over 2. Oh, I'm kind of lucky here. You're like, why are you lucky? Because look up at number 8. Looks like we ended up with the same period. So with that being the case, I'm just going to go ahead and fill my other values in. But here's the tricky one. I'm going to make a note of this. The fact that my A value was negative means my graph changes a little. Yeah. We're going to start going down instead of up since my A value is negative. That's the only time this happens. So I still am going to start at 0, but I'm going to go down, then back up to 0. So basically, it takes my graph and it flips it over. But again, that's the only time that that happens, is if I start on that downward track. So, but that time they just asked for a sketch of the cycle. They already had an equation, so we don't have to really worry about that. So no big deal. So then we get down to 12. And now we're kind of starting to get towards the end here. Find the period of the sine curve, then write an equation. Okay, so if I've got to find the period, I look at this first and I'm like, okay, let's see. What can I do to try and figure this out? Well, maybe I figure out how many cycles there are first. So I'm like, okay, so here's 0. Here's 2 pi. So I need to figure out how many cycles I've got in here. So I'm like, all right, so let's see. So down, back up. There's 1. Up, down, back up. There's 2. Up, down, back up. There's 3. Up, down, back up. There's 4. So I've got 4 cycles, or that's my B value, because I got to figure out the period. That's the only thing that's my mystery value right now. So my period, and again, my cycles, I'm always trying to figure out how many cycles there are until I get to 2 pi. I mean, I could stretch it out further, but I really don't need to, since the formula asked me just through 2 pi. How far do I get? So I get there, and I'm like, okay. So my period is going to be 2 pi divided by 4. And I'm like, all right, let's see here. So, and actually, we might touch on 13, because 13 I'm noticing right now has got a weird point to it. Yeah, we might have to chat about that. Okay, so 2 pi over 4, or reduced down, is pi over 2. So when I make my equation, y equals, first I got to figure out what my amplitude is going to be here. Where does it look like that maximum is about? About 1.5. That's fine. So about 1.5 sine. Now, before I write something, remember, it's the b value you're using here for x. Don't use your period value here, okay? Because when I do the formula, it's my b value. So that's my formula. There's my period, and I'm good. Now, I'm glad Michelle had mentioned something about 13, because 13 is weird. You're like, why is it weird? Well, if I look at this, I'm like, my period, it's like it did down, it did a halfway up, and then it's like done. How am I supposed to deal with that? So here's how we can adjust. How long does it take for it to do a full cycle? Let's see. So down, up, back to 0. Where am I at right here? 2 pi, 4 pi, 3 pi's in the middle. So if my period here is 3 pi, okay, because that's one total cycle, okay, so it went more than the 2 pi. It was kind of weird. But again, now I know my period is always 2 pi over b. And I know my period here is 3 pi. So I've got to figure out b this time. It's kind of doing it backwards from what we did at number 12. And you decided to start to see how, man, there's a lot of different ways you can do this stuff. So 2 pi equals 3 pi times b, just cross multiplying, and then solving it. To get b by itself, b is going to be 2/3. And now it looks like I got everything I need for my graph. So, okay, what's my a value going to be this time? -2. Because I see the 2, and I'm tempted to write 2, but look at, is it opening up or down to start? It opens down to start. So that's why I got to put the negative in there. My amplitude is 2. But since it opens down, it's negative with that. And then I take my b value and stick that in. Okay? And you're starting to see why we're going to spend so many days doing this, because we've got to make sure that we've got this stuff down as we move forward. But the lucky thing for us is cosine's really similar. All right, last part to the back here. Find the period and amplitude of the sine function. Then sketch the function from 0 to 2 pi. Okay. So we'll tackle a couple of these. We'll get you a couple, and then we should be in good shape. All right, so easy part. Let's take care of that. My a value, my amplitude is 4, so that's not a big deal. Okay, my period, okay, my b value is 5. I just get from whatever's in front of theta, x, those things are interchangeable. So, first find my period, which is 2 pi over b. So 2 pi over 5 is my period. So I got my period, got my amplitude. I know I'm starting at 0, I know I'm ending at 2 pi over 5. And here's one thing I'm going to change in the directions for what we're doing, because I really don't want to turn this into panic. Okay, sketch each function. Okay, for one cycle. We're going to keep doing it the way we have, where we start with 0, we end where our period does, and I just want to get the graph in the middle. Because trying to make that expansion at this point isn't going to work incredibly well. So just for a cycle. So I still got to figure out, what's in the middle of all these things. And these numbers can get weird. So like what's in the middle is 0 and 2/5. If I don't know, easy enough to take care of. I need to know where the middle of 2/5 is. So I take 2/5 and I divide it by 2, which is 1/5, or pi over 5. Okay, well, I still need to know what's in between these other two. Okay, what's in between 0 and 1/5? Okay, 1/5 divided by 2, fraction form, 1/10, or pi over 10. And then my last job is to find out what's in the middle here. Now, again, there's two ways you can look at it. You can say, hey, this is 1/10, this is 2/10, this is 3/10, but 3/10 doesn't reduce. This is 4/10. Or, like we've done before, you can take 1/5 and 2/5, add them up, and then divide by 2. I just want to continue to stress to you that there's ways to be able to get to the answer. It doesn't all have to be one way. So once I have that, and I know my amplitude is 4, and now I just do my thing. It's a positive a value, so we're going to open up. So up to the max, 0, down to the min, 0. And I expand that out and I work it. And then I'm going to give you one bit of help on 20. I'm not going to do 20. We're just going to rewrite this because I think that might confuse some of you. This is really 3 sine 1/2 theta. So your b value there is going to be 1/2. Because I know sometimes people look at that, they're like, is the b value 2? I'm like, nope. Just means we're going to look at it like we would a fraction for that one. And then my last one, at least the last one I'm playing with, and then we'll get you off and rolling here. Because we did a good chunk of this. I think we did more than half of it, actually. So here, my amplitude is 1.5. My b value is 6. So again, to get my period at this point, it's 2 pi over 6. And again, if you need to do some math enter to reduce it, hey, do what you got to do. Got my amplitude and my period. And then we're just going to do our sketch, and we're going to be good. So I got my amplitude. Got my 4 points. Know I'm starting at 0. Know I'm ended at pi over 3. And now again, it becomes just understanding how this breaks down. So, if I'm not sure what's in the middle of 1/3 and 0, again, if you're dividing by 2, it's like multiplying by 1/2, so I could even think of it that way. But other words, you can just do 1/3. Whoa. Let's start that again. 1/3 divided by 2, 1/6, or pi over 6. I got to cut that in half again, so I'm going to divide that by 2, which is 1/12, or pi over 12. And again, start looking for patterns. That's what so much of testing everywhere is anymore. It's just, do you understand patterns? So I have 1/12, 2/12 reduced is 1/6. My mystery line is 3/12, but that reduces to 1/4. And then I'd have 4/12, which reduces to 1/3. So I got all my values. And now it just basically becomes positive a value. So we go up to start, then down, and back up. And our sine curve is ready. So again, between this and yesterday's, you've got a few more to practice with. When we start getting towards the quiz preview, we'll kind of start putting this all back together. We're going to start the cosine function tomorrow, which is very similar to this, except for one little change at the start. But otherwise, you're going to see a lot of consistent things with this. But don't just let this go and be like, oh, I'll do all this later. Finish some of these off so you get that connection made, and we'll take a look at some more tomorrow.